Hello, calculus fans. Okay, we're going to learn the substitution rule. In Calculus 1, we learned the chain rule. And the chain rule tells us this. If we differentiate f of g of x, we're going to get f prime of g of x multiplied by g prime of x. All right, so let's give an example of that. So if we want to do the derivative of sine of x cubed, we do the derivative of the outside function, so the derivative of sine is cosine. Keep the inside alone, but then we have to multiply by the derivative of the inside, so this right here comes from the chain rule. Also in Calculus 1, we studied antiderivatives. So based on this calculation, we know that sine of x cubed is an antiderivative of 3x squared cosine of x cubed. So antiderivatives, that's just going backwards. We also learned the indefinite integral notation, and if we want to express our antiderivative that way, then we can write that the integral of 3x squared cosine x cubed dx is equal to sine of x cubed plus c. The right-hand side in this case gives us the most general antiderivative of 3x squared cosine of x cubed. Now let's say we were given the problem of computing this integral, or this antiderivative. So the method that we're going to be using is called the substitution rule. So the way we do it is we let u equals x cubed, and then we can say that the derivative of u is du by dx equals 3x squared. And then we're going to use the differential notation. We'll write du is equal to 3x squared dx. Now remember that the du by dx is not really a fraction, but for a lot of the things that we're going to do, we can sort of interpret it as a fraction. Now I'd like to go back to the original integral, which was 3x squared cosine of x cubed dx, and I'd like to make a substitution. Now you should notice that I've colored things. So the x cubed is colored in red because that was the substitution that we made, and then the 3x squared dx, that's going to turn into du. In fact, we should be able to see that now. So the x cubed turn into u, and the 3x squared dx turn into du. Well, now this is an easy integral to evaluate. We just end up getting sine of u plus c. And then to finish, we should replace that u with x cubed, and this gives us our final answer. Anytime we make a substitution, we always have to return to the original variable. And that's what we've done here. Okay, that's all for now.